Okay, so now that we've mastered the speed calculation, we're going to look at velocity. We want to be able to describe what it is and calculate it and see what is the difference between velocity and speed. So again, describe what the word is, explain why it's a vector, and then for any of us, which should be most of the class, if not all of you, that will be doing the higher paper, we want to explain why motion in a circle involves constant speed but changing velocity. So we've just looked at this equation. Speed is equal to distance divided by time. This should be in our books. It's an important equation. The speed of the object tells us the distance that the object has travelled in a given amount of time. It does not give us any idea of direction, and that is why it is a scalar quantity. So looking at this car, the first car, our speed will tell us how fast he's actually travelling at. Whereas if we look at his velocity, we know what direction he's going in. So again, here's a green box, an important definition. You may need to pause the video to write it down. So the velocity of an object is the speed in a given direction. So an object travels at 20 meters per second. Then we are stating its speed. Okay, so look at the first car. So this car's speed is 20 meters per second. We're just saying how fast it's going. We're not saying where it's going. We're not saying where it started, where it finished. We are just stating its speed. Whereas if I look down at the second car, I've just said that this car is traveling at a speed of 20 meters per second to the right. That's the important part there. That 3 words, to the right, is telling me the velocity of the car. It's telling me the direction in which the car is going. Because velocity includes both magnitude, recap, magnitude means size, and direction, therefore our velocity is a vector quantity, okay? Because when we're looking at that second car there, I now know how fast he's going, but I also know what direction he is going in. So make sure again that first box should already be in your books. If not, now's the time to get it down. And our second box, okay, you will notice they are the exact same apart from we've added in and direction. Okay, so for velocity it is the exact same equation as speed. I'm just adding in that direction. You may need to pause the video to write this down. Okay, so a person is walking in a straight line from point A to point B. They cover about a 50-meter distance. This takes them about 40 seconds. Pause the video now and try and calculate their velocity. Okay, so we should have just used the exact same equation as we've been using all lesson. Speed is equal to distance divided by time. I've got a distance of 50 meters and I've got time of 40 seconds. So speed is equal to 50 meters divided by 40 seconds. If I've been asked to calculate the velocity, however, I need to add in the direction. So if I look at my little compass over here, I know he's going south. So therefore speed is equal to distance divided by time. 50 divided by 40, it gives me a speed of 1.25 meters per second, but to make a velocity, I must add in that he is going south. If I leave out that word south, then I have lost my marks. I haven't calculated what I've been asked for. Okay, so this is a section that is for higher tier only. Again, like I said, that is most of you guys. So if I'm looking at my car, he's stuck on a roundabout, okay? He's just going around and around and around. How do I calculate his velocity? How do I know what direction he's going in if he's just going in a circle? It's not a straight line. So this is a special case of velocity. and that is for objects moving in a circle, okay? And when an object is moving in a circle, we know that most of the time we can say that they might be moving at a constant speed. So this shows a car, he's moving around his circular racetrack and he's going at a fairly constant speed, apart from when he stops the top, because I couldn't figure out how to get him to keep going around. But he is going, let's pretend that he is going at a constant speed, constantly around and around and around. So the direction the car is shown by the arrow. So the arrow shows me that he's going that direction. He's going down and around. Even though the car is moving with a constant speed though, his direction is constantly changing. That means his velocity is constantly changing as well. So if an object moves at a constant speed in a circle, then its velocity is constantly changing, even though its speed is constant. So please write that down in your books. It's an important thing to note that even though this car is moving around and around, he's going at that same speed, going around and around, actually his velocity is constantly changing. He is changing his direction every second he is on that roundabout. So this also includes an object that's going as part of a circle. So imagine again we go back to our bus. Our bus going around that corner. Our bus slows down to go around the corner and he might be going at a constant speed, but he is changing his velocity. His velocity is constantly changing as he goes around that corner. Okay, I'd like you now to answer the next worksheet, and please use graph paper when drawing your graph. Remember, for your graph paper you must use pencil and ruler, and you must also plot your points accurately as possible.